know if you can notice
Yeah.
that difference, but all right. It says to write an equation for the parabola whose vertex is at 3, 6, which passes through 4, 4. Okay. So do you remember the standard form of a quadratic?
AX squared plus BX plus C.
Yes. And so there's that form, ax squared plus bx plus c. And then there's also the form for a in vertex form, which is a x minus h squared plus k. Which would be more appropriate for this question based on the answers? Basically, I'm asking you, like, do the answers look more like the one on the right or the one on the left?
The one on the right.
Yes, yes. So that's h and that's k. Okay, so notice that we just put those values in. So it's a parentheses x minus 3 squared plus 6. Based on that, are there any answers you can eliminate?
Probably A and B.
Yes, yes, good. Okay, now what is the main difference between C and D?
The -2 and the positive.
That's right. So the main difference here is putting that that number in here is figuring out that number. To do that, you're supposed to put this point in for x and y, but there's a slightly better way. Okay, so let me show you that now here. If I just make a quick sketch of this graph here. So here's 3, 6, here's 4, 4. If this is the vertex, does the graph open up or down to go through this other point? Basically, I'm asking you, does it look like this or this?
Right side up.
Okay, so it has to be the one on the left, because the only way to get from the vertex, which is the min or the max, is to go down like that.
Oh.
Okay, so that helps you to answer this question, because the difference between C and D is that C opens up and D opens down.
Okay.
Okay, now if you don't like that approach, like, hey, maybe I wouldn't remember that. The other option is to put 4 in for X and 4 in for Y. Okay, and solve for A. So we're going to do that here. So the first thing to do is subtract the 6 from both sides of the equation. The -2 equals A. 4 minus 3 is 1. 1 squared is 1.
1.
So A is -2. Okay. Any questions on that or thoughts on that?
No.
All right. Okay, so let's take a look at another problem here. Actually, the instructions are given here. All right, here we go. So, all right. So this one says to factor the expression. This is a certain type of factoring. There's about 5 total, and then there's variations on those 5. Do you remember anything about how to factor this in this form?
Wouldn't you find like the lowest common factor between 11 and 28, or the greatest?
So you're looking for two numbers that multiply to 28
and add to 11.
Yes.
Okay.
Now they're kind of helping you out here with the answers. You can see it's some variation on 4 and 7. So which is it? Is it +7, +4, +7, -4, +4, -7, -4, -7? Which one?
Would it be A?
It is. And that's because they're both positive, right? So the answers, they both have to be positive to get to 28, or negative to get to 28. See how D, -4 and -7 get you to 28? But then to add to a positive. Sorry, what were you going to say? I didn't mean to interrupt you there.
It wouldn't be +7 if you added it up. It would multiply to 28, but would not add to +7.
Right, it would add to -11, and we don't want that. All right, so here's a new problem to look at here. Hope this is okay what we're doing for today's lesson. So This one says the same instructions. It says to factor. This one's a little bit harder, but because the answers are here, maybe there's some hope that you might remember how to do it. I don't think we did any factoring together, but I will tell you the first type of factoring that you should always do is find the greatest common factor, if there is one. Basically, is there a number or a letter that goes into both?
Uh,
Is there a number that goes into 6, -4, and 8?
2.
2. Okay. So notice if we factor a 2 out, actually, I need to rewrite it here because I want to show you the GCF factoring. So if you put a 2 on the outside, what goes on the inside parentheses comes from dividing each of these by 2. What would that be?
Dividing them by 2.
Yes.
X squared minus 2x
Good.
plus 4.
Good. Very good. So what would your answer be? A, B, C, or D in this problem?
D.
It is D. Now, kind of an aside here. What is 4x divided by x?
X?
So let me draw another analogy.
4?
What is 3 divided by 3?
1.
Why is it 1? That is correct. Why is it 1? Tell me in your own words why that would be 1.
Because 3 times 1 is 3.
Okay, that's a good answer. I appreciate the creativity on that one. What we're looking for is that they're the same on the top and the bottom. Okay, so while what you said is correct, what I was looking for is it's kind of like Jeopardy. It's like it's the top and the bottom are the same. So when the top and the bottom are the same, and this 4 over x is really 4 times x over x. X over x is the same, so that becomes 1. 4 times 1 is
4.
4. Good. Okay, that matters for the next question that we are going to look at here. So let me grab this here. All right, here we go. All right, minus 12x squared minus 8x. The instructions say, again, to factor. And I mentioned previous problem, the first type of factor you always try is the greatest common factor, the GCF. And it can be a number only, like the last problem. It could be a variable only, or it can be both. Okay, so in this problem, minus 12x squared minus 8x, first look at the 12 and the 8. Is there a number that goes into both?
4.
4. Now, because the leading term is negative, you factor out a -4, or you factor out the negative with it.
Okay.
That takes care of the number part. Then the variable part. Between x squared and x, you look for the one with the smaller exponent. Which would that be?
X.
X. So -4x is your GCF. You're going to divide each of these by -4x. So the way to do this is to do it number over number, like -12 over -4. Can you tell me what that would be?
3x.
The whole thing is 3x. Yeah, you got it. The x squared over x, there's x times x in the top, 1x in the bottom, comes just x. How about here on the right? -4 over -8 over -4.
+2.
Plus 2, and the x's cancel. Any questions on that? Let me give you one to try here. Make it a little bit easier here. 9x squared minus 15x cubed. 15x cubed. So what is the GCF?
3.
Okay, that's part of it. That takes care of the number
3x.
part. So it is x, but to what power? Basically, you're looking at the 2 powers.
Squared.
3x squared. Okay, so what I'd like you to do is tell me what goes in parentheses here when you divide each of those by 3x squared.
3 and 5x. Well, negative 5.
Like this?
Yeah.
Looks good. All right, good job. Let's look at a new problem here together. All right, could you read the instructions for us, please?
Identify the vertex and the axis of symmetry of the parabola. Identify points corresponding to P and O, or Q.
Good, good. So this is actually very similar to kind of stuff you see in your class. You get this sort of like, all right, I got to find the vertex. I got to find the axis symmetry. I got to identify P. I got to identify Q. There's actually like 4 parts to this question.
Mhm.
Okay. So, that's A, that's B, that's C, that's D, right? Now, because it's multiple choice, you can maybe like look at the easy stuff first, like P and Q, and figure that out. Not sure. But I just want to use this as an opportunity to remember what the vertex is. So the vertex, we kind of looked at this in problem 1. It's either the min if it opens up, or it's the max if it opens down. I had a student tell me, you probably heard this before, it's like a smiley face and a frowny face.
Yeah.
It's the math face and then the everything else in life face. So do you see the vertex here? Is it a min? Is it a max? What do you say?
It's a math.
It's a max if it opens down. Does this open down?
Sorry, minimum.
Okay, maybe the brain, sometimes you see one thing and you say the other. What is that point right there? Can you give me that ordered pair, please?
-3, 2.
Try again. Going left. I don't know how easy this is to see, but you're going left 2 and then up 2.
-2, 2.
-2, 2. Okay. Can we eliminate any of the answers here? Like, can you, when you look at A, B, C, and D, are any of them out because of this?
B, or no, wait, yeah, B and D. Well, B and C, sorry.
Yes. Okay. So that's important to do. Like, now the axis of symmetry, I'm going to draw it here. It goes right through. Boy, I don't like that thick line. It goes right through the vertex. So the idea is like it's a mirror. It's separating the left and the right side. Like the left side looks the same as the right side.
So the axis of symmetry would still be.
It's an equation. In this case, x equals -2. Yes, no, maybe. Okay. All right. Now, points P and Q, that's just labeling them. But you can see that both A and D have the same axis of symmetry. So then it just comes down to labeling the points correctly. I believe letter, I don't know why this is P prime and Q prime. Anyway, point is we'll just go with A. Not sure. Maybe they meant.
Because
Anyway.
P is negative.
I didn't make this question. This is just me going to the internet. So,
Okay.
All right, let's look at another question here. Whoa, I went too far. All right, there we go. Is this large enough to see or not? Is it too small?
Too small.
Really? Interesting. Okay, let me check. Are you viewing this on the same device you normally view this on?
Yeah, it's also because I don't have my glasses.
Oh, okay. All right. Well, here, let's do. I can see that's wondering what the problem was before. All right, let me do this differently. Is this large enough to see the way I'm writing here, or is it still too small? Okay, so let me write an equation here, x minus 2 squared plus 4. And let me write the standard form underneath of it, which I don't have the right pen color I want. My pen, let's do, I use blue a lot. That blue looks good. Okay, so we have y, it keeps doing that. I don't want the chunky. Y equals x minus h squared plus k. Okay, so the vertex is h comma k.
Mm-hmm.
Do you see how these negatives are lining up here?
Yeah.
So the h value is 2 in your problem, and the k value is this 4.
Mm-hmm. So
Okay,
it's 2, 4.
2, 4. And the reason it's 2, 4 is because the signs line up perfectly. Now let me give you another one here. Let's say it was x plus 5 squared minus 3. The vertex for this one, oh, sorry, go ahead.
-5 and +3.
So the one on the inside switches, but not the one on the outside. And that's what I was going to get to, is that could be tough to remember. It's like, why is the one on the inside? It's because it's opposite in sign on the inside, but the one on the outside is whatever it is. Does that make sense?
Yeah.
Okay, so let me have you try another one here. Let's say it's y equals -3x minus 1 squared minus 4. What would the vertex be for this one?
1, -4.
Very good. All right, now does this one open up or down? And it's based on this number out here in the front. Do you remember that rule?
Down.
Yeah, so if a is less than 0, it opens down. If a is greater than 0, it opens up. Right. Any thoughts on that? Questions on that?
No.
Okay, so let's do some more factoring. Tends to be a lot of factoring on some of the stuff here that we're going to see. Right. All right, so here's a new problem I found. It says factor to solve. It's kind of like the one we did earlier, where you had to find two numbers that add to 28, or multiply to 28, but added to 11. Now your focus is on the -15 and the -2. So what I mean by that is you've got to find two numbers that multiply to -15, but add to -2.
I don't. Mm, I don't. I don't know.
Okay, so here's how to think about it. Let's start with 1. 1 times what number gets you back to -15?
-1 and
-15.
15.
Or like, yeah, what I'm about to hear is the other one, which is -1 and 15.
Yeah.
Okay, now does 2 work? Can 2 get you to 15?
No.
But 3 works. 3 times what number gets you back to -15?
-5.
-5. And then you also have the other sign, -3 and 5. Do any of these pairs add up to -2?
3 and -5.
Yes. So do you remember what you write in parentheses over here on the left?
Would it be the x plus 3 and x minus 5?
Yes, perfect. Now that's if you're asked to factor. Now, since we're asking to solve, you have to set each of these equal to 0. Okay, can you tell me what the final answers would be?
Would it be x is -3 and x is 5?
Yes, perfect. Okay, one more here real quick before we close out for today. Let's say I give you x squared minus, let's see, 2x minus 24, okay, equals 0. So kind of the same scenario. You're trying to find two numbers that multiply to -24, but then add to -2. Okay, Okay, so try not to focus so much on the fact that it's negative. Just look at it as 24. Just look and say, okay, how do I find two numbers that are now 2 apart? Kind of. That's kind of what you're looking for here. Okay, so can you think of two numbers that are 2 apart to get to 24?
2 and 12.
Okay, so like 2 and negative 12, negative 2 and 12, they're I would consider them to be like 10 apart, roughly.
Yeah.
Or you could say 14, but we're getting closer. Like if you said 1 and negative 24, that's 23 apart.
Mhm.
So does 3 work?
No.
You sure? 3 and negative 8?
Oh.
It's okay. It's probably been a long day. 4 and negative 6, negative 4 and 6. Do any of those get you to negative 2?
Would it be 4 and negative 6?
Yes. So if you're at x plus 4, x minus 6 equals 0, set both of those equal to 0, what would your final answer be?
X equals negative 4 and x equals 6.
Perfect. Really good. All right. I'm going to go ahead and stop the recording right here for today.